going to kind of put this list back up a little bit so you can see it, just so you get the hang of what you're looking for. First question is there a perfect square in the denominator? Is there? Is b to the fourth a perfect square?
Yes.
It is, yes. B to the fifth would not be, but anything to the even exponent is. So it says separate the radicals. So we're going to separate these, the square root of 25 over the square root of b to the fourth. And simplify each. So square root of 25 is 5, and the square root of b to the fourth is b squared. Okay, and there's nothing else that we can do with that. That's it. Okay, let's look at, Well, we took the square root, so once you take the square roots, we don't keep the radical. These are both perfect squares. So, all right, let's look at another one. Okay, is there a perfect square on the bottom? Yeah, and you want to make sure you consider both the number and the variable, but yes, they're both perfect squares. So we would separate it into 2 square roots. Square root of the bottom is, square root of 16 is 4, and the square root of t squared is t. Okay, so no radical on the bottom is a good thing. The one on the top, 75, is not a perfect square, but there is a perfect square in there, right? 75 is 3 times 25 and 5 times 5. So 75, inside you have 3, 5, and 5. That pair of 5s has to come out. So what would that give me? 5 radical 3. Okay, one quick thing. We don't have it in this case, but you do want to look before you say you're totally done and make sure 5 and 4 don't share a common factor, your whole numbers, but they don't. So you're done.
If they do.
If they do, say you had 8 and 4, or 6 and 4. If they share a common factor, you need to simplify those down like you would a normal fraction. Okay? All right. You know there will be some with variables. Okay. So the first question is there a perfect square? Is the denominator a perfect square? It's not. So the second thing you're going to do before you split these apart is you're going to look at the entire fraction. And don't worry about the variables yet, we'll get there, but do 12 and 27 share a factor? Does the same number go into 12 and 27? 3. So you're going to want to simplify these down. Divide out the 3. If I divide out the 3, so I'm just going to set up a new fraction over here. If I divide 12 by 3, that is 4. And if I divide 27 by 3, that's 9. So I've reduced my fraction. Now I have to look at the variables. This goes back to chapter 8, your exponent rules. If you have 3 on top and 1 on the bottom, okay, I'll remind you of the rule. That's really a to the first. The rule is the top exponent minus the bottom. But if you're thinking of this visually, one pair of a's, top and bottom, will cancel out. What does that leave you with? 2 on top, right? A squared. So if you did 3 minus 1, on top we have a squared. Okay. This looks a little nicer, but are we done? You still have a fraction in your radical. would it be a good idea for me now to split them up? Is there a perfect square on the bottom? Yes. So if the answer is yes, then we split it up. The square root of 9 is 3, and 4a squared also happens to be a perfect square. May or may not be, but what's the square root of 4a squared? 2a. So that is totally simplified. Okay, we have one more thing to talk about. And this is going to answer the question, what happens when a radical remains on the bottom in your denominator? Okay. There's a rule in math, you cannot, or you're not supposed to leave an irrational number in the denominator. Your square roots, your simplified square roots, are irrational numbers. If you were to put them in your calculator, you'd get a non-terminating decimal. Okay, that's not how we leave fractions. So what this might look like, say you've simplified everything else. Maybe you had something more involved than this, and you simplified it down, and you got this. You're not done, because this is not allowed left in the denominator. You can have one on top, just not on the bottom. Okay, we do the other things first because the other things might take care of that whole issue. So I want you to think of it this way. This is kind of a, accessing what you learned previously. If I had 2/3 plus 1/6, you learned a long time ago you cannot add two things that are not alike, right? You can't add thirds and sixths. But I could change thirds and turn it into sixths, right? How do I do that?
Multiply them by 2.
I multiply the top and the bottom by 2. And the reason we do the same thing to the top is because we don't want to change the fact that it represents 2/3. We just want to make it look different. And multiplying by the same number, top and bottom, is the same as multiplying by 1. So this would turn into 6, and we'd be fine. Now, not that we're going to be adding at this point, but I wanted to point out that multiplying by 1 doesn't change it, it just changes the looks of it. So, to get rid of this radical on the bottom, we call this rationalizing the denominator. Okay? So you're going to rationalize the denominator. You'll get used to that term the more we use it, but you're going to pick the fraction that you want to get rid of, the radical that you want to get rid of, and we're going to multiply the top and bottom by the radical we need to eliminate, because it's a form of 1. So I'll do this in a different color. We're multiplying the bottom by the radical 5 and the top by the radical 5. Radical 5 over itself is simply 1, so that's allowed. But what happens is when I multiply the radical by itself, it gives me a pair in the bottom. On the top, a whole number times the radical stays just that, a whole number times the radical. Now, if there were two radicals, you'd funnel them in together and simplify. But here we just have 2 radical 5. But the important part is that's a pair, right? So that's a perfect square, which means that is just 5. And the 2 radical 5 stays 2 radical 5 on the top. Now, because some of these get a little bit more involved, the only ones that I'm going to have you rationalize, I had to cut the assignment down from 51 to 47. So the last 4 I've taken off of the assignment. We'll worry about those Monday. So don't do 48 through 51 right now. Okay. On your sheet, it says 28 to 42 even, 44 to 51, but you're going to do 28 to 42 even and 44 to 47, right?